Behavior of polymorphic methods inside constructors. The hierarchy of constructor calls brings up an interesting dilemma. What happens if you're inside a constructor and you call a dynamically bound method of the object being constructed? Inside an ordinary method, the dynamically bound call is resolved at runtime, because the object cannot know whether it belongs to the class that the method is in or some class derived from it. If you call a dynamically bound method inside a constructor, the overridden definition for that method is used. However, the effect of this call can be rather unexpected because the overridden method will be called before the object is fully constructed. This can conceal some difficult-to-find bugs. Conceptually, the constructor's job is to bring the object into existence, which is hardly an ordinary feat. Inside any constructor, the entire object might be only partially formed. You can only know that the base class objects have been initialized. If the constructor is only one step in building an object of a class that's been derived from that constructor's class, the derived parts have not yet been initialized at the time that the current constructor is being called. A dynamically bound method call, however, reaches outward into the inheritance hierarchy. It calls a method in a derived class. If you do this inside a constructor, you call a method that might manipulate members that haven't been initialized yet, a sure recipe for disaster. You can see the problem in the following example. Glyph draw is designed to be overridden, which happens in round glyph. But the glyph constructor calls this method, and the call ends up in round glyph.draw, which would seem to be the intent. But if you look at the output, you can see that when glyph's constructor calls draw, the value of radius isn't even the default initial value 1. It's 0. This would probably result in either a dot or nothing at all being drawn on the screen, and you'd be left staring, trying to figure out why the program won't work. The order of initialization described in the earlier section isn't quite complete, and that's the key to solving the mystery. The actual process of initialization is 1. The storage allocated for the object is initialized to binary 0 before anything else happens. 2. The base class constructors are called as described previously. At this point, the overridden draw method is called, yes, before the round glyph constructor is called, which discovers a radius value of 0, due to step 1. 3. Member initializers are called in the order of declaration. 4. The body of the derived class constructor is called. There's an upside to this, which is that everything is at least initialized to 0, or whatever 0 means for that particular data type, and not just left as garbage. This includes object references that are embedded inside a class via composition, which become null. So if you forget to initialize that reference, you'll get an exception at runtime. Everything else gets 0, which is usually a telltale value when looking at output. On the other hand, you should be pretty horrified at the outcome of this program. You've done a perfectly logical thing, and yet the behavior is mysteriously wrong, with no complaints from the compiler. C++ produces more rational behavior in this situation. Bugs like this could easily be buried and take a long time to discover. As a result, a good guideline for constructors is, do as little as possible to set the object into a good state, and if you can possibly avoid it, don't call any other methods in this class. The only safe methods to call inside a constructor are those that are final in the base class. This also applies to private methods, which are automatically final. These cannot be overridden and thus cannot produce this kind of surprise. You may not always be able to follow this guideline, but it's something to strive towards. Exercise 15, 2. Add a rectangular glyph to polyconstructors.java and demonstrate the problem described in this section. This section shows how polymorphism calls the most derived method, even before completely initializing the object. During construction, you see output of area equals 0 because the base class constructor calls draw, though this isn't obvious in the code.